Well, welcome back to our discussion about graphs and applications of quadratic functions. And on this video, we are going to discuss how do we graph parabolas that are in the form f of x is equal to a times the quantity x minus h squared plus k. So that's a little bit different than graphing parabolas when they are in the form f of x is equal to ax squared plus bx plus c, or standard form. So let's take a look. Okay, so to begin this dialogue, we're going to do a little bit of a discovery kind of task. And I'm going to walk you through the first of these examples, and you're going to pause the video and do the next two on your own, and then I'll quickly run through them, okay? So the first thing I'd like you to do is take these three functions, f of x, g of x, and h of x, and use your algebra skills to change them or transform them into standard form. And what I mean by that is you're going to take this binomial that's being squared, multiply it out, and then combine like terms. So let's do this first one together. Okay, for this first one, the first thing we're going to do is multiply x plus 4 times x plus 4. And we've got that minus 6 on the end there. Then when we multiply that out, we'll have x squared plus 4x plus 4x plus 16 minus 6. And when we combine like terms, we get x squared plus 8x plus 10. Okay, so that's what I'd like you to do with these other two equations. So take a second, try these out on your own, and then we will go through them when you come back. So pause the video and I'll be right back with you. Okay, welcome back. So for this second example, we'll go through it quickly. We're going to multiply x minus 3 times x minus 3 and multiply that whole thing through by 2. So I'll have x squared minus 3x plus 9. And that whole quantity is multiplied by 2, and then we subtract 5. So if I distribute that 2 through, I end up with 2x squared minus 6x, which is minus 12x, plus 18 minus 5, or 2x squared minus 12x plus 13. Now for h of x, we're just going to take that binomial that's being squared and multiply it out. So 6 times x minus 1/2 times x minus 1/2 plus 1. So when I multiply that x minus 1/2 times x minus 1/2, we'll get x squared minus half x plus 1/4. And we're going to multiply that all by 6. So distribute that 6 through. We'll end up with 6x squared minus 3x minus 3x plus 3 halves plus 1. And when I combine the 3 halves and the 1, we would end up with 6x squared minus 6x plus 5 halves. Okay, so this is the first step of this discovery process. All right, so now I'm going to take those three equations that we got, and notice I just put them up close to the ones that we started with. Okay, now what I would like you to do is what we did in the first video, where we found the vertex from the equation in standard form. Okay, so again, I'm going to walk you through the first one. If I take this and find the x of the vertex by saying negative b over 2a, we'll have negative 8 over 2 times 1, or negative 4. Now when I substitute that in to find my y value, when I find f of negative 4, I'll have negative 4 squared plus 8 times negative 4 plus 10, which all equals negative 6. So my vertex is negative 4, negative 6. Okay, so pause the video, find the vertex for g of x and h of x, and then come on back. Okay, welcome back. Here we go. G of x. We're going to say the x of the vertex for that function is negative 12 over 2 times 2, so positive 12 over 4, which is 3. And then f of 3 will end up being negative 5. And so my vertex is 3, negative 5. And for h of x, we would have negative 6 over 2 times 6. So positive 6 over 12 is 1/2. And then h of 1/2 will end up being 1. So our vertex is 1/2, comma, 1. Okay, so we're almost done with this process, and I promise there's a reason why we're doing this, okay? All right, so next thing we're going to do, we're going to look at the vertex that we found from the standard form and compare it to our original form of our equation. I want you to do that for all 3 of these, and I want you to see what you notice. Is there anything you notice about the x coordinate? Is there anything you notice that is the same for this x coordinate and this equation, this x coordinate, this equation, this x coordinate, and this equation? And how about the y coordinate? And you probably notice that the x of our vertex is what's inside the parentheses with x, except it's the opposite sign. So it's like taking what's inside the parentheses and setting it equal to 0 and solving. Okay, now what about the y? The y is what ends up on the outside of what's being squared, and there's no sign change at all. But you notice that's true with all of these. And so we really don't have to go through this process if we have an equation which is in this form, because we are already kind of given, in quotation marks, our vertex. And so sometimes we call this vertex form of an equation when it's in this form, because we can pull the vertex directly from the equation. So we can say that if a function is in this form, the vertex will be the coordinate hk. Okay, got that? All right, so don't write these in standard form, but identify the vertex of these equations. Can you find the vertex of this first one? Hopefully you said the coordinate 919. How about the second one? Well, I hope that you said -2, +5. And the last one should be +1 and -237. Okay, and so the whole reason why we are doing this is to save ourselves some headache when it comes to graphing. All right, so now that preps us to graph this parabola, building on what we already did. Because the only thing that's really different here is instead of finding the vertex by using that -b/2a thing, we can just find the vertex by looking at the equation. And from what we just did, we can find the vertex by saying it's the opposite sign of what's in with x and what's on the outside of the squaring. Our vertex will be at the coordinate 1, 4. Okay, so now let's find our y-intercept by finding f of 0, or where x is equal to 0. And when I sub the 0 in, I've got 0 minus 1 squared, which will be 1. Make that negative. So -1 plus 4 is going to be 3. So my y-intercept is the point 0, 3. We plot that. And then we find our x-intercepts by taking the function f of x and substituting a 0 in where f of x is and solving for x. Now remember, this goes back to your skills about solving a quadratic using the square root property. So let's shift this quantity to the left-hand side, take the square root of both sides, and make sure we remember that plus or minus, and then add a 1 to both sides to isolate x. So we get x is equal to 1 plus 2 or 1 minus 2, which is 3 or -1. So our x-intercepts, if I plot those, are right here. And remember what we did last time? We looked at our vertex and then chose 2 x values, one directly to the x, one directly to the left, and one directly to the right, and found some additional points. Now, if I do f of 0, I already know that, but I know f of 2 will be 3 as well. So if I plot 2, 3, add that to my graph, I have a really nice upside down U shape taking place. So when I sketch it, oh, look at that, how pretty. We've got that upside down parabola. So now let's analyze it. Domain, just like anything else, when we're talking about quadratics, this goes infinitely to the left and the right. So negative infinity to positive infinity. Our range, low to high, negative infinity to the highest y value there is, which is 4 with a bracket. Draw your axis of symmetry. Name it. That's x equals 1. Is there a max or a min, and what is it? In this case, we have a maximum at the vertex, and that maximum is 4. And where does it occur? That happens at x equals 1. Now let's look at the interval of increase. Our interval of increase is the left-hand side of this graph, the yellow portion. So what's the domain of the graph in the yellow portion? That's negative infinity to 1. And the interval of decrease is the other side, so 1 to infinity. Now let's look at where is this function above the x-axis. So looking at the domain of the graph that is above the x-axis, that would be everything from this x-intercept to this x-intercept, so from negative 1 to 3. And now where is f of x less than 0? So where is the graph falling below the axis? So we should have two pieces. We should have this piece, and the domain of this piece is negative infinity to negative 1. And then this piece over here will be from 3 to positive infinity. And there we go. All right, in our next video, we'll talk a little bit about characteristics of parabolas, and we'll see you then.